All right, hello all. This is section 2.4, just a video note. So this is something you need some extra paper. So it's not room. I didn't make a page to write this information on. So you're going to need a separate sheet of paper. Yes. And so as you can see, I've written things down. So why don't you pause the video and write everything down and then come back to listen to the video. Okay, welcome back. So this is section 2.4, exact equations, and this is where the first exam will stop. And so I wanted to talk about, give a sort of an intro. Now the book discusses it, and like I said, the book probably gives more detail in all honesty, which is a good thing, but if you don't really understand what's going on, it can be confusing. So I wanted to just state some things. I take things, and one thing that I suggest to students, if the book that you're using for your class doesn't work for you, try to find a different book. You know, you can search online, see if the library has anything, and try to find a book that actually works for you. I might have some extras in my office if you want to stop by and take a look at different books. Okay. All right. So here we have this differential here. So y dx plus x dy equals 0. And what we notice is that this is actually the product rule. We were talking about the product rule in regards to taking sort of partial differentials and doing the product rule. So with the product rule, treating, x and y like a constant depending upon what, how you're deriving it, right? So this is the derivative of xy, the derivative of x is y dx, and the derivative of y is x dy. And so that's sort of the product rule. So you can see the product rule is coming back into play, just like when we were talking about the integrating factors. Now, here's the thing. We're looking for, if we integrate both sides, because again, we're still trying to solve for our solution, which is y, right? We're trying to find a function y of x, or y of whatever your independent variable is. And so if you take the integral, so once you find this d of xy, right? Because what we'll see, you're going to be given this, and you're going to have to try to find that. And so once you find that and say the differential xy equals 0, then if you integrate both sides, then the integral, we found out that the integral of 0 we know is c, right? So it's going to be xy equals c. That's how we get that, okay? And so let's say if z equals f of xy, so this is a function of two variables, a continuous function of two variables, and we're assuming that on some region, okay, some region R is continuous. It doesn't necessarily have to be continuous everywhere, but on some closed region we say it's continuous. And not only that, its partial derivatives are also continuous. So I think this is more Calc 3, because we didn't talk about this in Calc 2 or Calc 1. So this is sort of more Calc 3, I believe. So you may have to sort of maybe go back and review that. Well, then its differential, which is also known as the total differential, is dz, okay? So again, we're taking the derivative of that, and it's going to be the partial derivative of f with respect to x dx plus the partial derivative with respect to y dy. And we're going to call that 1, okay? Another way, although, again, this notation is helpful to see, your independent, dependent, and things of that nature, but because right in that little script D, and be careful because you need to make sure you can differentiate. Oh, look at that. Differentiate derivatives. Get it? No. Okay. We can differentiate from a partial derivative versus just doing the regular derivative. And so the notation f sub x, and I think we talked about this when the first week of class, when we talked about notation. And so this represents the same thing as that. Okay, so they're representing the same thing, just as the partial derivative with respect to y is representing that. Okay, so you can look at it like that too. It just may be more helpful in the top, and throughout the examples, I think I use them interchangeably, but you can use whichever one you're comfortable with as long as it's clear of what's going on. All right, so again, I wanted to save some time, so pause the video and write this out, okay? We should be back now. So again, if z of f of xy equals c, then 1, so going back here, we said this was our 1, becomes df of dx plus let me be careful. The partial derivative of f with respect to x dx, the partial derivative of f with respect to y equals 0. Okay, and we're going to call that number 2. Okay, so for example, let's say if x squared minus 5xy plus y cubed equals c, then 2 will give us, well, first you have to take the partial derivative with respect to x. I think I want a different color here. Let's go back to red. With respect, no, let's try yellow. I don't think I did that. Okay, I'm wasting time now. All right, with respect to x. And so notice that means you treat y, you take the derivative and treat y as a constant. So we're going to get, well, that first term is just going to give us 2x, right? This term here, if we're treating y as a constant, then we sort of group that 5 and that y together, and then the derivative of x is just 1. So that's how we get minus 5y. And of course, that will go to 0. Okay, dx plus, now we do the same thing, but this time we're taking it with respect to y, and you should get, so you can pause the video and sort of double check to make sure you understand the partial derivatives. You should get 3y squared minus 5x dy and equals 0 because the derivative of a constant is 0. Okay, so the question is, well, how can we work backwards? And so in other words, because when we're given our problems, it's going to look like this. So how can we work backwards to show that it's going to give us, so in other words, how can we show that this equation here is really the same as this equation? Okay, and so the goal will be to show that m of xy, so this m is a function of x and y dx, n is a function of x and y dx. That should be dy, yes. That should be dy. And that equals the derivative of f of x, y. Okay, so taking the derivative of a function in two variables is taking the partial derivatives. Okay, so that's something to keep in mind. So we have what we call, we have this nice criterion. Okay, I think that's how that's said. Yes, for exact differential. And so it tells us that if we have a function, again, m of xy and n of xy, and these are continuous functions with continuous first partial derivatives in some region. Again, it doesn't have to be on the whole entire domain, the entire, from negative infinity to infinity, but on some rectangular region, where x is between a and b, y is between c and d, then it's continuous and its partial derivatives are continuous. Then we say that m of xy dx plus n of xy dy is an exact differential if the partial derivative with respect to y, so now you flip it. So this is m, the partial derivative m with respect to y, you need to show that the partial derivative of n with respect to x, you need to show that they're equal. And if they're equal, that means it is an exact differential and you can solve it accordingly. And we're going to show that now. Okay. Oh, so this can probably be done. I thought I might need 2 videos. If I quit my commentary, then we can just finish this in one video. All right, so example 1a. So now you can go to your sheet. And I want to go over this example because when I come to class, I want to go over some things, but finish this packet, but I want to make sure you have at least one already completed by the time you come to class. So hopefully you are listening to this before class. Okay, so here we have the equation and it's in your packet. This is from your homework, section 2.4, number 3. And it says the expression 5x plus 4y dx plus 4x minus 8y cubed dy equals 0. Okay, and again, I like whenever possible, and you should think about this even if I don't create steps for you all, maybe when you're going back over your notes, try to see if you can create steps for yourself, because if you can think of sort of a systematic way to solve these, then that'll just help you better to retain, even if you don't, an exam or quiz, write down step 1, step 2, right? Okay, but step 1, let's clearly identify our m of xy and n of x y, which we did, right? And so that is step 1. Step 2, now we have to determine, confirm it's an exact equation. Okay. Well, how do we do that? Well, we take the partial derivative of m with respect to y, and we take the partial derivative of n with respect to x, and if they are equal, then we have an exact equation, and we can continue. If they are not, so one, make sure you do it correctly, but if they're not equal, that means it's not an exact equation. You can't proceed with as usual, and you need to go back to either maybe it's a linear, maybe it's separable, maybe it's an exact. Well, this is exact. So we learned 3, and it's another one. Okay, I'm drawing a blank, but it's another one. All right, so m of y in this case. So again, we treat x as a constant, and so the derivative with respect to y, the partial derivative would just be 4. Okay, and then similarly here, we're taking it with respect to x, so y is treated as a constant, and what do you know? We get 4. All right, so thus m of y equals m of x, and this is an exact equation. All right, and so what that tells us is that m of xy, which equals 5x plus 4, and n of xy, which equals 4x minus 8y cubed. Now, I didn't write this, but something you should know, if we do have this exact equation, then what that tells us, and I'm going to have another video. I want you to watch a video. Khan Academy actually has a nice video sort of explaining this and proving this a little deeper. But what this tells us is that m of xy dx plus n of xy dy equals the partial derivative of x with respect to f with respect to x dx plus the partial derivative of f with respect to y dy. Okay. And so that's going to equal the derivative of, the function in 2 variables. Now, here's the thing. If you look, then clearly dx and dy is there. So that means that this has to be what? Well, it has to be the partial derivative of f with respect to x. And this has to be the partial derivative of f with respect to y. So in other words, what we have is that m of xy, which in our case is equal to 5x plus 4y, it equals the partial derivative with respect to x, and n of xy equals the part 4x minus 8y cubed is the partial derivative with respect to y. Okay. Or again, f this notation here. I'm going to stop this video because it's going to take more than 2 minutes to finish, and I don't like going over 15 minutes. So I'm going to stop here, and you will continue on in the next video.